Hello, in this video we're going to be taking a look at solving quadratic trig equations. Now this is actually quite straightforward to do given you know how to, obviously solve quadratics. If you can't do that, I'll link my video on that in the description so you can go look at how to solve a quadratic, then come back and also solve trig equations too, and I'll link my videos on them below, because without these two skills it's going to be tough to do something that involves both of these things. I'll timestamp the examples that I'll work through below so you can kind of skip through to whichever one you want to see. And if this video is useful, do go over to my channel where I have loads of other maths tutorials, and you can also go over to my website, which I'll link in the description, where you can see all of my videos in one place and they're a bit easier to navigate through the different topics. Thanks for watching. So let's look at this first question where we're asked to solve cos squared of x equals 0.25, and we're solving it on the interval between 0 and 360 degrees. Now there's actually a really common misconception I see when people solve these types of equations. So the first thing you want to do is make just cosine of x the subject. And so we're going to do that by square rooting both sides. So that's going to give me, well, cos of x equals, well, what's the square root of 0.25? Well, that's just a half. And a lot of people will write cos of x equals a half and solve that, and then they think they're done. But when we're square rooting, we need to take both the positive and negative solution. And so this results in two different equations. We get cos of x equals positive 1/2 or cos of x equals negative 1/2. And we need to solve both of these equations to get all of the solutions. So let's start off by solving the one on the left hand side. So cos of x equals positive 1/2. And so to do this, I'm going to draw a rough sketch of the graph of cosine. So I know it peaks at 1, goes down to -1, then goes back up to 1. And it's got 90, 180, 270 and 360. So if I do inverse cos of a half on my calculator, that tells me what x is going to equal, and I'll just write down all of the steps to make it really clear what I'm doing, and that tells me x is going to be 60 degrees. So I can zoom into my graph and I can mark up that solution there at 60. Now using the symmetry, I know I've gone 60 degrees to the right of the origin, so if I go to 360 and I go back 60 degrees, that's going to take me to another solution here at 300 degrees. And on the interval we're solving in, that's it, we've got both of those solutions. So there are two solutions there, 60 and 300. Let's now do the exact same thing, but for cosine x equals negative 1/2. And so to solve this, the first thing I'm going to do is inverse cosine both sides, and that's going to tell me x equals inverse cos of negative 1/2. Now this gives me a solution of x equals 120 degrees, and so if I go back to my picture that I've drawn, and I'll get rid of the old working out that I had just to make it a bit clearer, I'll change colour too. So we've got one solution at 120 degrees, so I could mark that on here at 120, and so because I've gone 120 degrees to the right to get that solution, I'm going to go to 360 and go back 120 degrees, and so 360 minus 120 is 240, and that's the other solution. So let's write that down, x equals 240 degrees, and that's it. So this equation actually had 4 solutions. Now just like with our other videos, you could check to see if there were any other solutions by adding or subtracting the period of cosine of x from all of these 4. But the period of cosine of x is 360 degrees, and so if I add or subtract it from any of these values, it's no longer going to be in my interval, so I don't need to bother. Let's look at the second question, where here it looks a bit more complicated. We've got 2 sine squared x plus 3 sine x minus 2 equals 0, and we're solving it between 0 and 180 degrees. Now this is what we call a hidden quadratic. It's just a quadratic equation, except rather than being written in terms of x, like we usually see, it's written in terms of sine of x. And so what a lot of people can find useful is actually to do a substitution, where we're going to say let some letter, I'll use the letter u, equals sine of x, and then we're going to rewrite the original equation. So if I've replaced each of these sine of x's with a u, what is the equation now going to be? Well, it's going to be 2u squared plus 3u minus 2 equals 0. And this is something hopefully we can now factorize and solve. So let's think, how would we factorize this? I don't know what method you use, but you might like to multiply these two numbers together. That gives me negative 4. And then we look through our factors of negative 4 until we find a pair that add or sum to give positive 3. We could have 4 and negative 1, because 4 multiplied by negative 1 is negative 4, but if we add them we get positive 3. We then rewrite the original quadratic using these two, so we get 2u squared plus 4u minus u minus 2 equals 0. Factorise the first two terms, so that's going to be 2u, u plus 2. Factorise the second two terms, that's going to be minus 1, u plus 2 equals 0. And so we get our two brackets, 2u minus 1, u plus 2. Now I haven't really explained that process, I've just done it, but I'll link my video on this process if you want to factorise like that. But you can factorise it however you like, you'll always get the same answer if you've done it correctly. So we now know from factorising this equation, we're going to have two solutions for u. Because we've got two things multiplied together to give 0, so either this bracket's going to be 0, or this bracket's going to be equal to 0. And so what is that going to be? Well, 2u minus 1, if that equals 0, I could add 1 to both sides and divide both sides by 2, so that gives me u equals a half. If my other bracket equals 0, I get u plus 2 equals 0. Subtracting 2 from both sides, I get u equals negative 2. Now remember, we weren't trying to solve this equation to find u, we were actually trying to find out what x was. So if we go back to where we made this substitution at the start, I said u was just equal to sine of x. So what I'm going to do is I'm going to undo that substitution, and wherever I've got a u, I'm going to write back in sine of x. So I have to solve sine of x equals a half, or sine of x equals negative 2. And like always, I'm going to draw a rough sketch of my function. So sine of x is going to look something like this, between 1 and minus 1. And I could label on a few key points, so 90, 180, 270 and 360. Well, looking at this first equation here on the right, hopefully you can see there's no value of x that you can give me that will make sine of x output negative 2, because the range of this function, or the values that it can output, only go from positive 1 down to negative 1. And so what I'll do is I'll just cross out this equation because there are no solutions to it. Which leaves us just to solve where sine of x equals a half. Hopefully we can do this quite nicely, so we'll do inverse sine of a half on our calculator, or you might just know it, and that gives you x equals 30. We can then zoom into our nice picture, mark on the solution we've just got. Using the symmetry, well, I've gone 30 degrees to the right of the origin to get this first solution. So if I go to 180 and I go back 30 degrees, that will take me to my second solution at 150 degrees. And so I can write that in, x equals 150. Now from here I would usually add or subtract the period of the function to both of these solutions to see if there are any more. But the period of sine of x is 360, and so if you add or subtract 360 to either of these numbers, well, you're going to be well outside the range of values that you would want. And so there's only two solutions to this equation, and we're done. The last question we're going to look at is this one here, which looks probably the most confusing, and that's solving tan squared of 2x minus 20 minus 2 lots of tan 2x minus 20 minus 3 equals 0 between 0 and 180 degrees. So the first thing we're going to do is to do this substitution to make this quadratic look a bit nicer. So I'm going to say let u equal tan of 2x minus 20. Let's now rewrite our equation. It's going to turn into u squared minus 2 lots of u minus 3 equals 0. Let's now factorise this. So I'm looking for factors of negative 3 that sum to give negative 2. So I could write down the factors of negative 3. Well, negative 3 and positive 1, they would work because they sum together to give negative 2. And so I could factorise this and I get u minus 3 multiplied by u plus 1, and that equals 0. Now because I've got two things multiplied together to give 0, either this first bracket's going to be 0 or this second bracket is going to be 0. Well, if the first bracket equals 0, I get u minus 3 equals 0, which is going to give me u equals 3. Or if the second bracket equals 0, I get u plus 1 equals 0, which gives me u equals negative 1. Now remember, we're not trying to solve to find out what u is, we want to know what x is. So I'm going to undo this substitution and replace u back with tan of 2x minus 20. So we've got tan of 2x minus 20 equals 3, or tan of 2x minus 20 equals negative 1. And so I'm just going to solve both of these one at a time to get all of the solutions. So I'll start off with this one, I'll move it over here. So the first thing I'm going to do is draw a rough sketch of the graph of tan of x. So it's going to go up like this, have an asymptote at 90, and then it's going to go back to 0 at 180 degrees. And I'm only going to draw out the first period of this function. So the next thing I'm going to do is do inverse tan of 3. And that's going to tell me what 2x minus 20 is. So that's inverse tan of 3. And I'm just writing this out just so you can clearly see everything that I'm doing. So inverse tan of 3. On my calculator, that gives me 71.6 to 3 significant figures. So 2x minus 20 is going to equal 71.6 degrees. From here, I can now solve to make x the subject, because remember with tan, within each period, there's only ever going to be one solution, so you don't need to search for the other one. So the first thing I'm going to do is add 20 to both sides, and this is going to give me 2x equals 91.6 degrees. Then I'm going to divide both sides by 2, and this gives me x equals 45.8 degrees. Now, what is the period of this function here? Well, there's this 2 in front of the x, which is going to be a stretched scale factor 1 over 2 parallel to the x-axis, which means the period of this graph is going to have halved. So the period of tan is 180, and so the period of this function is going to be half that, it's going to be 90 degrees. And so now what I'll do is take this one solution that I found, and I'm going to add or subtract 90 degrees until I've got all of the solutions within the period we're solving in, which is between 0 and 180 degrees. So let's add on 90 to this solution here, and that's going to give me another solution, let's write it down, of x equals 135.8 degrees, which is in my interval, so I'll accept that solution too. But if I add 90 again, hopefully you can see it's going to give me 225.8, which is now no longer in my interval, so I can stop there, and I found both of these solutions. Now what we need to do is solve the other equation we created, which is tan of 2x plus 20 equals negative 1. So what I'm going to do is sketch out the graph like always. So I'm going to draw out that first kind of initial period. So it's got this asymptote here at 90, and then it goes back to 0 at 180. So let's do inverse tan of negative 1, and that tells me 2x minus 20 is going to equal inverse tan of minus 1, and that is going to give us negative 45. So 2x minus 20 is negative 45. Now, I suppose actually you don't really need to draw the graph of tan to solve this, but if you want just to visualize it, I will. You can see that actually at negative 45, I haven't drawn that section of the graph on, so I'm just going to extend it backwards and add on the other asymptote here, which would be at negative 90. And so the solution my calculator is giving me is here. But remember what we said, for tan, there's only ever one solution in each period. So drawing the graph isn't really that useful, because whatever your calculator tells you, you can just work with that number. But if you wanted to, you could add the period of tan, 180, to get this solution over here, then rearrange to make x the subject. But actually, I'm just going to rearrange to make x the subject now. So I'm going to add 20 to both sides, and that gives me 2x equals negative 25. Then we can divide both sides by 2, and we get x is negative 12.5 degrees. So that is the solution the graph has given us. Now, just because this isn't within our interval, it doesn't mean this solution isn't useful, because we're now going to use this to find the solutions that are within the interval we're interested in. And the way we're going to do this is by adding and subtracting the period of the function. So tan of 2x minus 20, this 2, halves the period, so it's still 90 degrees. And so I'm going to take this negative 12.5 and I'm going to add 90 degrees to it. That's going to give me another solution at x equals 77.5 degrees. And I could add on 90 again to this, and that's going to give me x equals 167.5 degrees. You can see both of these are within the interval we're solving in, and so I get these two additional solutions. And that first one that I had that wasn't within my range, I can cross it out and reject that one because it isn't valid. And so we've solved that equation. So it's a bit of work, but hopefully you can see it wasn't too bad. It's just following the same process that we were doing with our standard trig equations. So hopefully this video was useful. If it was, do go over to my channel where I have loads of other maths tutorials, or you can go over to my website that I'll link in the video description, where you can see all of my videos in one place and they're a bit easier to navigate. Thanks for watching.